So let's do these kinematics calculations. A motorcycle with an initial velocity of 6 meters per second accelerates at a rate of 4 meters per second squared. Calculate the time required for the motorcycle to reach a velocity of 36 meters per second squared. So if you remember, what are the things that we need to do? You need to draw a diagram. Okay, here's my motorcycle. Okay, and it's traveling in that direction, and it has an initial velocity of 6.0 meters per second. Okay, and its acceleration in that direction is equal to 4.0 meters per second squared. And the question is asking for the velocity, or the time it takes for the velocity to be equal to 36.0 meters per second. So after making your drawing, you make your SUVAT table. S, we don't know, didn't give us that in the problem. U is equal to 6 meters per second. V is equal to 36.0 meters per second. Acceleration is equal to 4 meters per second squared. And time is what we're looking at. So we need to find a formula that has U, V, A, and T in it. Okay, so let's go back to our SUVAT formulas. We have V squared is equal to U squared plus 2AS. Can't use that, okay, because we have S in the formula. So I'm going to erase that. Okay, then we also have another formula where acceleration is equal to V minus U divided by T. I think that's the formula we're going to have to use, okay, because I don't have S in it. It's the only one that doesn't have S. So to solve for time, I'm going to rearrange this formula. T is equal to V minus U divided by A. So T is equal to 36 minus 6 divided by 4. Okay, so the answer is going to be T is equal to 30 divided by 4, which is 7.5 seconds. Okay. Dr. G travels down a super long water slide with a constant acceleration of 4 meters per second squared. Assuming his initial velocity was 3 meters per second after a running start and jump, calculate his displacement down the slide after 5 seconds. Okay, so without the diagram, or here I'll just do the diagram. I'm a ball, okay, and I am traveling with an acceleration of 4.0 meters per second squared. My initial velocity is 3 meters per second. And the question is, what is S after T is equal to 5 seconds? So put that all into my SUVAT table. S is what we're looking for. U is 3 meters per second. V, we don't know. My acceleration is 4.0 meters per second squared. And T is 5 seconds. So I need to find a formula that has S, U, A, and T in it. Okay? So we have this formula. S equals UT plus 1/2 AT squared. That's a formula I found in the data booklet. Okay, so S is equal to 3 meters per second times 5 seconds plus 1/2 times 4.0 meters per second squared times 5 seconds squared. And if I put that all into my calculator, it should give me 65 meters. Okay. A jumbo jet airplane lands on the runway at Katoka International Airport with a speed of 70 meters per second. The airplane reverses its engines to apply braking and comes to a complete stop after 29 seconds. A, calculate the acceleration provided by the engines on the runway. Okay, so here's my airplane. Okay, and it has an initial velocity of 70 meters per second, and then it comes to a stop at T is equal to 29 seconds. Okay, is when it comes to a stop. Okay, so the first question is asking me for acceleration. So SUVAT. Okay, we don't have S, but we have U, 70 meters per second. v is equal to 0 meters per second. A, we're trying to find out what that is, and t is 29 seconds. The only formula that has u, v, a, and t in it is a is equal to v minus u divided by t. Okay, so if I plug in all those numbers, 0 meters per second minus 70 meters per second divided by 29 seconds is going to give me an answer of negative 2.4 meters per second squared. That's for number 1. And for part B, calculate the length of the runway. Okay, now we're looking for S using all those variables. Okay, so the length of the runway is going to be, I can use a whole variety of things. So I'm going to use one that we haven't used before. V squared is equal to u squared plus 2as. Let's try that one. Okay, so to find S, I would just have v squared minus u squared divided by 2a is equal to s. And if I plug in all the values for that, okay, v is 0 meters per second squared minus 70 meters per second squared divided by 2 times my negative 2.4 meters per second squared acceleration, and that should give us a value of 1 kilometer. All right, last one, and then we'll take a break. A bullet accelerates the length of a barrel, which is 0.75 meters, with a magnitude of that acceleration. With what speed does the bullet exit the barrel? Okay, so without drawing it, I'm just going to go straight to my suvat and see what I have. I have 0.75 meters. I have my acceleration, which is 5.35 times 10 to the 5 meters per second squared. I'm looking for the exit speed. That's what the question is asking for. And I have my initial velocity, which is 0 meters per second, and I don't have time. So, suva, which ones can I use for that? Okay, so I can also use v squared is equal to u squared plus 2as. Okay, and my final velocity is going to be the square root of u squared plus 2as. Okay, and what's that going to be? V is equal to the square root of 0 meters per second squared plus 2 times 5.35 times 10 to the 5 meters per second squared times 0.75 meters. That gives me a velocity of 896 meters per second. All right, I'm going to split this up and then make videos for the next ones.